Hello, and welcome to the counter equation part 5. So in the previous parts, we went through HB, HC, and B. Now we're going to mush it together, essentially, into the counter equation. So the counter equation, right, we were solving the area of any polygon. So to recognize that, to put that in a symbol, I'm going to write AP. AP, area, polygon. It's all it is. It's as simple as that. And now we're going to start combining stuff, okay? AP, we're going to use summation notation. Forgive me, you're probably wondering, oh, Billy, you wrote it in different sections. Yeah, that's because if I didn't, it'd be a monster, and I literally wouldn't be able to fit it, all right? It's just nicer this way.
Well, isn't it just the same thing, like 3 different times, basically?
Yeah, just imagine this is in a little symbol output. Yeah, exactly. So area of a polygon, we're going to do 1/2, because these are essentially trapezoids, times summation notation. We have our omega minus 1. Because of our little trick, we can really subtract the 1, because the last one will always have 0 area, of course. And I'm going to put alpha equals 1 down there, just like that. See that? All right, now we're going to start plugging all this stuff in. Okay, I'm going to write, there's really no need. I guess for here I could just write parentheses. I'm going to use brackets. I feel like he's in brackets. I'm going to use brackets. I'm going to write HB alpha, right? You see that? Okay. HB alpha plus HC alpha. Sorry about that. Close the brackets because now we're going to put times B. It's a big B. Alpha. Okay? And that is it. That is the counter equation. All right? That's
the entire thing?
That is the entire thing.
Wait, just the bottom one is the entire thing, or the entire thing is the entire thing?
The entire thing is essentially the entire thing. Basically,
that's a lot.
It is a lot. Because you have to put this in. So now HB alpha looks small, right? HB alpha equals this entire thing.
I see.
HC alpha, small, it's this thing. B alpha, this thing. All right, so just to recap a little bit on some of the terminology you see inside. We went over this in the previous video, but I'm going to write a key really quickly. The key is very simple, omega. I'm going to write it very quickly. Omega equals the number of sides. Oops, forgot the E. You guys can read that. I said it. Theta n, we're using n, equals, I'm just going to write the angles. That's angel. Whoopsie daisy. Angles.
The math guy can't even spell angle. Guess you should have took some more English too.
Yeah, probably, okay. SLK, that's the side lengths. You can really see where I get this from. SL, side lengths. I am that simple.
I'll be straight up, I didn't even know that's what that meant. I just thought SL was just a placeholder thing.
No, that's all it is.
What's
side
the K
length.
then?
The K is the number.
Here, but...
K, so
okay,
there's
so
SL1.
K is the placeholder.
Yeah.
Okay.
K, yeah.
So
SL1,
I know
2,
we're kind of
3.
going backwards here, but I had to know.
Oh yeah, no, you're fine.
By the way, I'm here. It's Danger Dan 19. I'm like the guy who's like doesn't know anything about math, and I'm trying to interpret all this. So, I'm the one that edits his videos. We're doing this in my house right now.
That's why we have a different setup and everything.
Yeah, probably should have said that at the start, but whatever.
It's all good. Say it now.
Yeah.
And that's it. That's the key. But really, this is it. If you don't need HB, HC, and B if you just plug it in, of course. But you can relate, like, that's very daunting. Imagine trying to do that all in a stretch. It'd be very hard to do that on this kind of, well, I would need like a really big whiteboard. I was kind of daunting getting to this part in the series because of how daunting this is, but this makes it less daunting. So this is the counter equation in its long form with everything plugged in instead of the, you know, the HB, the HC, and the B. It's replaced by what you guys see in the video. Really quickly, there is one important distinction to make. You notice the equation starts, you got the 1/2, you got that big summation notation, and then right after the beginning of the brackets, you have that 2. That 2 is a simplification. You could kind of view it as a simplification. That is because, I don't know if you can see, if you go to where the HC would normally be, in the bottom I have K equals alpha. If you can do that, but then you have to double the HB, and that's what I've done. It's just a slight little thing you could do to kind of simplify it. You know, you could use this counter equation this way if you'd like. Basically, that's all. But yeah, this is the counter equation in its long form. All right, and I don't think there's anything else to say in this video. This is the wrap up. This right here, right? This right here is the counter equation. All right. If you think about it, it's not really that hard. It's not that bad. It's just to make everything modular where it fits truly with any polygon. You have to well expand it. You know, you have to make it so you get, you know, you go side by side, right? That way you just do it until you're done with all the sides. Well, except for the last side, right? The -1, of course. All right, that's it. I'll see you in the next video.
Bye.